Okay.
All right.
Well,
Get
thank you very much. Thank you very much to the IP Showcase for giving me the opportunity to talk and kind of share what we've been doing at Dolby and our partners been occupying us for the last few years. I've never presented on the move before, but it's good because no matter how bad my jokes are, you're not going anywhere. So, right. Case in point. So, Serialized ADM in 2110-41. Okay, so this talk is I've not done this kind of venue forum before, so I'm kind of assuming I'm going to start right at the beginning. So I know it's going to be boring for a few of you who are really kind of familiar with this topic. Hopefully I'll be invited back. We can go into some more advanced topics, but we're going to start at the beginning for now. So problems with audio. Okay, we made a lot of progress with audio, but the reality is that a lot of the problems with television audio are still with us today. There's poor personalization choices, the accessibility choices. When they do exist, often they're given a presentation which is inferior to the main presentation. And things like headphone, all you can get is stereo. You know, we can do better than that. We have the technology to do better than that. It's just a matter of the kind of delivery and getting the pipes ready. Okay. So NGA, I just want to explain the kind of basic concept of NGA, next generation audio, what it means. It's a kind of umbrella term for lots of different things. We've got immersive, so Dolby Atmos. You know, this is already with us today. It's been actually live for quite a number of years. The other areas like personalization, accessibility, these are more kind of nascent and emerging. In terms of devices, it's about trying to make sure there's a not consistent experience across devices. That's impossible, but that the experience translates across those devices and it's meaningful to the user, whether it's headphones or a SEM14 speaker system. Okay. All right, now there's a bunch of technologies that need to come together for us to go down that kind of NGA road. And there's lots of things we could do with NGA. You're here with NGA, lots of kind of crazy stuff, ideas. I mean, lots of things are possible, but what we are focusing on really as a first step for broadcasters is separating out the music and effects from the dialogue. That gives you multi-language. It gives you accessibility. It gives you dialogue enhancement as well. So this is just, it's a single change. But don't underestimate the simplicity of it. This is a big lift for all the organizations involved. But in terms of the effort involved and what you get back for it, it's a really good trade-off. So that's where we're focused. And there are obviously other things that you need to enable that. We need IP to get the channels that we need metadata, and we need a codec to get it to the consumer.
You hit the mute button. There's an optical mute button.
Okay. So what does IP give us? Well, the two things you need for next generation audio, we need more channels. We can't do a whole lot with 16, and we need metadata. Okay, so first of all, in terms of channels, so when SDI, 3G SDI, and we get the 32 channel addition was made, this was actually a big opportunity. Would really be helping us out now, but the reality is the devices are not there. We're limited to 16. We assume that is always going to be the case. Really, with 16, it's kind of, there's only so much you can do. With IP, it's, to all practical purposes, unlimited. Because you can associate multiple streams together. So, and NDI also has a kind of, to all practical purposes, unlimited channel count. Okay. So, how would we use our channels? Well, it kind of depends. You've got You've got legacy services. Often people want to do simulcast and they want to include legacy stuff as well. You 514 M&E, music and effects, so it's that separation we need to do, and then adding on the dialogue tracks as well. And maybe there could be metadata in there as well as the legacy. So you can see how you burn through the 16 very quickly, and some organizations want to send more than one effects bed, maybe for rights reasons. And NBC have certainly cited that. So with that, with 514, you've blown through the 16 channel straight away. So really, with IP, we've solved the channel problem. So what about the metadata? Well, there's been a solution in place for a very long time, ADM, the audio definition model, standardized by ITU 2013. Dolby has been using that for many years. So we've got a data model that's already good and can be used we can use that in broadcast in the way that it's been used in post-production. So serialized ADM is really just a frame-based version of that. And there was a need recognized at some point, okay, yeah, ADM's great for file-based workflows, but for streaming, we need something different. A lot of standardization work has gone on, getting in the various transports and also in file-based formats. Okay, and it works in new IP workflows, which is what 2110-41 is all about, also in legacy as well. There's the concept of profiles in ADM generally, but that serialized ADM uses the same, inherits that same data model. That's where you would have one set of audio for you in production, where typically maybe you'd have a large number of objects or channels, and then something that is used around a facility where you're feeding an encoder, like maybe for linear playout and so on, something which is much, much simpler, much saner, much closer to what we've been using in the past. But with that enables the new features as well. So something like a 514 plus 2D, 2 languages plus AD, something along those kind of lines. The emission profile is standardized by the ITU. It wasn't published in spring 2024. There's kind of political issues at the ITU. Nothing's being published, but it is frozen. Everybody is using it. And actually, if you get an ADM file and you put it in media info today, it'll tell you whether it's compliant with the draft standard. So it's already, you've already got tools out there everyone can use that are free. So how in practice, like this serialized ADM, how does it kind of get on the wire? Well, it depends a little bit on the transport that's used, but it's basically the same idea in most cases. You take the ADM, which is the description of your audio, tells you what you've got, plus extra stuff like loudness, downmix parameters, whatever. Could be object locations as well. Then you add in a transport mapping to map those various audio elements to your tracks, your physical audio tracks. So that creates another bigger XML, which is then compressed normally using just a simple gzip compression. And that's placed repeatedly on the wire, typically once a video frame. The standard doesn't specify a repetition period, but once a video frame is just what people generally, we've seen they've gravitated towards doing. So one question that I often get up is, okay, this SMPTE 2110-41, why didn't you go with SMPTE 2110-40? So there are a number of reasons for that. Really, it's mostly down to the kind of legacy that comes with SMPTE 2110-40 and limited bandwidth. And so I think it was Paul Briscoe that started the work way early on to try and take care of some of the classic like VANC type applications. As time has kind of gone on, it was recognized, hey, there was work going on in AES, and that was combined with the work going on in SMPTE to use it as an application for audio metadata. But it's not limited to audio by any means, and in fact, Dolby is using it to carry video metadata for Dolby Vision as well. I'm just going to talk about audio today. Yeah. So in terms of the basics of 21-41, it is kind of pretty simple. There's an identifier which tells you what you've got. It's just a number. And there's one defined for, not for serialized ADM, strictly speaking, it's for what's called metadata guided audio. And the reason metadata guided audio, which is kind of an extra layer on top, is used is because that is used in MXF. So it's the same concepts being used in MXF as well as in SMPTE 2110-41 to enable easy kind of transfer between live and file for play out and so on. So in terms of standards, yeah, we got 21-41. That was published in March. Thank you to all the folks at SMPTE, John and others making that happen. We've got 2127-2, which specifies the mapping of MGA, which includes serial ADM, into 21-41. That was also published at the same time. And there's also actually another useful standard, is 2116, which tells you how to put serialized ADM into a 337 wrapper, which could go on AES3 or SDI and so on. So useful for legacy workflows. And it's really been a collaboration effort. This is not Dolby thing. It's not, we have a stake in it, but we don't own it in any way. And in fact, it's been a number of organizations that have contributed to this to get us to where we are today on a standards position. So given that we can put it in SDI and AES3, one way to put it on IP would be use transparent AES3 in SMPTE 2110, i.e. 2110-31. So why not do that? Well, there are two reasons. One is, okay, then you're putting the metadata in the audio channels and you need all that bitstream detection and all the logic around that. It's a pain. I've seen services go down because of this stuff, getting it right. It actually looks trivial, but it's not easy to get right on a 24/7. It's much easier if you're dealing with a native IP stream and you don't have to deal with the frame rapidity and the sync words and everything, all the complexity that deals with that. Also, the signaling is not explicit. In the SDP 21-31, all you know is it's AM 824. You have to start digging into the data to figure out what you've got. With 2110-41, you know you've got MGA. You can look in just at the STP and kind of figure that out straight away. So it keeps that separation between the control and data planes. Okay, so case studies, like who's been doing this stuff, who's looking at it, right? Two I'm going to highlight today. From the most important one is the Paris Olympics, and this was really a watershed, I'd say, for the whole kind of technology. It was, and actually I'll go into that in the details of that in a minute, but we also earlier on, we worked really closely with SRF, the Swiss German broadcaster, kind of fleshing out the ideas and testing things with proof of concepts and early versions of software, whereas on the France side, we're using real products from a variety of manufacturers, actually some of which are represented here. So the France TV case. So what's important here is we've got our feed coming from OBS, and there is a dedicated serialized ADM authoring unit produced by Younger Audio, and Roman is the product manager. He's sitting there at the back on the right, so you got any questions about that, ask him. But there was a unit there describing the feed coming in from OBS. Then there was another Younger unit downstream in the facility, which was describing the feed coming from the linear playout, the automation system. And there's a switching that occurs through the control, master control, which then switches between the two sets of authored metadata, along with everything else, the audio and video, driving the ATEM encoder. So the ATEM encoder doesn't care too much about what's going upstream. It sees the metadata changes, and it uses the new metadata set and reflects that downstream. So mostly it was about switching between 514, 5.1 stereo, that switching rather than the personalization or accessibility features. But, you know, the plumbing is all there. They've proven a lot. They're very happy with this workflow. It worked very well. So they're now looking at, well, what else can we do with this? Looking at those new features. Yeah. This, I'm not, the SRF was a couple of years ago. This is not so important now. It's complicated. I'm not going to go through it. I don't have the time. But the key thing we learned out of this was, one, we could get the streams across infrastructure that already existed. Two, that the concept of authoring upstream in the venue and then reauthoring within the facility, having the ability to do that, because everything's metadata based as opposed to being baked into the content itself, was really valuable to broadcasters. This was something they wanted. It could be giving the broadcaster downstream the ability to remix content if they so desire to do so. Okay. So with the France TV, and then also Canal Plus is the next one. They are just embarking on a big, very ambitious project, doing both live and also file-based workflows with MXF, with serialized ADM. So between these kind of projects, this is driving a number of manufacturers to get involved. This is not an extensive list by any means. In fact, I know Emotion Systems, for example, they are starting work on serialized ADM immediately after the show. And I expect there are others I've missed. This is just to send out the message, hey, this is not theoretical anymore. There are people putting real money on this. Checks are being signed. This is real. It's not theoretical anymore. Oh, also, if you have the time, come by the Ravenna booth, where we have a couple of products, the authoring unit and rendering unit from Younger Audio, the AI Expressor, and Bridge Technologies, VB440, just showing a simple kind of chain, and you can see the user interface. We can talk you through how those products work. It's in Hall 8, so quite close by. I'd be happy to help you if you want to kind of know more. So what kind of, think back to the problems that talked about at the beginning. How does serialized ADM, what does it give us that's kind of useful? Well, the M&E support, that gives you a lot of the kind of personalization and accessibility options that you need. Having bed and audio gains allows you to do that dialogue enhancement. So have a presentation maybe where dialogue is louder. The logical copies of audio elements, I'll come to that. Well, that's kind of useful. But there's, of course, a whole load of stuff which broadcasters are not thinking about now, but that's possible in the future. I think perhaps the most important one is binaural metadata. Okay, how are we doing for time? No, okay, 1 minute. Right, this is something we worked with SRF, and if you want to do 3 languages, 3 complete mains, 5.1, okay, 6 channels each, you need 18 channels. Bang, you're straight through your 16 channel limit. Okay, but if you split everything up and you have your 5.1 bed with 3 dialogues, you send the metadata and you actually do the mixing downstream, that actually saves channels. And they saw this as being really useful, because the reality is a lot of those pipes, They don't change quickly. But this is a way to kind of get more down that pipe or save money. Okay, so one thing, a lot of people, NGA, all this stuff, and they say, well, what's the killer app? What's the thing that's going to move the whole industry forward, right? Like, what is it, you know, as if there's some magic thing. The reality is there's no silver bullet, there's no killer app. You talk to the various broadcasters, everybody wants something different. They've all got different problems to solve. The key here really is the flexibility and agility that the system provides, that it could be kind of something different for everyone. And it gives you the ability to dream, i.e. there's a problem that we haven't thought of that it will solve for you. So we're not solving for one particular thing, we're solving for a whole group of things, but also about the things that we haven't even thought of yet. Okay, thank you very much for your attention.